All right, so let's just kind of review how we're going to solve and use our inverses. All right, let's start with our first one up here, our n plus 4. Okay, if you want to solve that for n, what are you going to have to do? You're going to have to subtract the 4, right? So you would have n equals, on the other side, a, and you're going to subtract that 4, right? It's gone from the other side because you started off with adding, right? And so to undo the addition, what did we do? We subtracted, okay? So let's look at the next one. So the next one is 3 times n. So this is multiplication. Yeah, so we're going to divide by 3. So when we divide by 3, we're going to get our n equals 3, no, sorry, the a divided by the 3. So to undo the multiplication, what did we do? We divided. We divide. Okay, let's look at the next equation. It's n squared. How are we going to solve that for n? We're going to have to root it. So we start with the square. And we have to take the root, right? So if we do that, so if we take the square root of both sides, we get n equals the square root of a. So that brings us to our exponent, what we were just working with. 2 raised to the n power equals a. Well, how can we find the n? We find the n by taking the log, okay? So it looks like this. We say the log of our 2. The 2 is our base. So log, let's see if I can get it better. Log base 2 of our a will give us what the value of our n, or in this case, exponent is. Okay? And that is called our logarithm. Okay? So if you have an exponent and you want to undo it, you will take the log.
Is that logarithm?
Uh-huh. And look at the top of your paper, Kindle, and also right here. Here's how to spell it.
Oh, logger.
We say it logarithm. Logarithm. It's kind of like the asymptote. It's kind of another funny word, right? Okay. So let's now take a look. Let's now take a look at our logarithm. Okay. So let's turn it over, and we're going to look at the graph. We're going to look at the graph. Now, what we have is, scoot up a little bit. What we have graphed right now is our 2 to the x power. All right, and we just talked about exponential and log functions are what again? What are they to each other? They are inverses. Is that right on my desk? Thank you so much. Okay, they are inverses. So if we have a function that is already graphed and we want to graph its inverse, how can we find it? How are inverse functions related to each other? What's the theme, whether you're trying to solve for it algebraically or whether you're trying to graph it? We flip, what do we flip? The x and y. Very good, thanks, Caitlin. We flip or we switch our x and y, okay? So we switch the x and the y. So they gave you the values of your 2 to the x. They gave you those. So to now graph your log function, you're going to come over here and you're going to reverse or flip your x and y. One other thing, when we are graphing inverses, what do they reflect over on the graph? No, not the x-axis. The line y equals x. So we're going to put that in as well. I'll try to do the best I can. You guys can get a little better. We're going to reflect, remember, over that line, y equals x, right? Okay, so switch your coordinates, then plot your points and see if you get a true inverse graph. All right, so if your points, if we were plotting these points, so if I was over here at 8, we got 3, and 4 gave us 2, and 2 gave us 1, and 1 gave us 0, and a half gave us -1, it's down there, and then a fourth, okay? So we ended up with something kind of like that. Did I get that right?
Yes.
Or am I off? Am I off on that 8? Yeah, I'm off on that 8. Hold on. Well, sorry. Okay, 8 gave us 3.
Don't even.
Okay. Yeah, does he even have his graph? Okay. All right, so here we go. Okay, so here we go. Here is our log function. Okay, so real quick, I want to talk about what's happening here. You had these x values getting really, really small, and these y values doing what as well? Were they getting smaller?
Yes.
So what's happening right here? Is it ever going to touch this y-axis? No. So what do you think that y-axis is to the log function? That's its asymptote, right? Okay, so your y-axis is the asymptote for the log function. So your y-axis is the asymptote. Oh, hold on, I have an extra letter in there. So the y-axis is the asymptote to your log function. The x-axis is the asymptote to your exponential. Okay? So that makes them inverses of each other. Okay? All right, so how do we write this log? How do we write this? How do we put all this together? Okay. So let's come down here, right here. If b of x equals a, then rewritten as a log, it would look like this. We would have log base of base b, so that's your base, of a. A is called our argument. Equals, yes, what is left is the x, which is our what again? What's our x? Is our exponent. Okay? Okay? So log base b of a equals x. Okay? So that's how you read it. Okay? You read this as log base b of a equals x. Log base b of a equals x. Log base b of a equals x. All right, I want you to say it with me. Ready? Log base b of a equals x. Do it again. Log base b of a equals x. One more time.
Log base b of a equals x.
Okay. So what is the log? The log is the exponent. Your log is the exponent. The log is the exponent. All right. So let's come down here and let's write them out. So what we're going to do now is we're going to take our function that is in exponential form and we're going to rewrite it into our log form. And then we'll take the log form and rewrite it into the exponential. So let's start off over here at a. Okay. I have 7 raised to the 2 power gives us 49. So let's rewrite that. So that is log what? Base 7 of 49 equals 2. The log is the exponent. Okay, let's do one more of those. Let's go down to D. So D, so we have the log base 9, go down to D. Log base 9 of 27 is 1.5. So there you go. We've got a decimal there, kind of what we started with, right? The 4.3. Now let's skip over here. Let's go over to, let's do H. Let's do H. It's in log form. Let's rewrite it back in exponential form. So we're going to start with our base. What's our base? 2 raised to the x power equals 64. Okay? So we can rewrite them as one or the other. If you start with one, you can always rewrite it as the other.
How would you word letter E?
Letter E, it would be log base 4 of x equals 9.
Okay, just making sure, because the X would interfere with
Yeah.
the other one.
Yeah, and we'll learn how to solve these as we move on in time. Okay. All right, so real quick, the last thing I want to show you, come down here to where it says common log. Okay, has everybody seen the little log key on your calculator?
Yeah.
You notice that it doesn't show a base? It just says log?
Yeah.
Okay. Because your calculator, it will only compute what we call common logs. Okay? And common logs use a base of 10. Okay? So if you have a logarithm that doesn't show you the base, you will always assume that it is base 10. So look at this first one real quick. So we have log base, it's not there, so we're going to say log base 10 of 100 equals 2. So let's go over here and rewrite it. So what's our base? What's our base? 10. Our base is 10 raised to the second power equals 100.
Hey.
There you go. You got it. Okay, let's see if we have time. Let's do M real quick before the bell rings. Jump over to M. So what's our base on M? It's not there, so we make it 10. So 10 raised to the fourth power equals 10,000. Okay? All right, so that's how we write them back and forth, and next time we will actually solve them. Okay, we'll actually find what those values are, but we are out of time.